Okay, we're going to get started with the second talk of this last session of PyCon AU 2018. Next up, we have Mark Smith with Publishing Perfect Python Packages on PyPI. Let's give him a warm welcome.
Thank you, everybody. I apologize for the last-minute change of title, but I suddenly realized there was a real opportunity for alliteration here, and I couldn't turn it down. Originally, the title was How to Publish a Package on PyPI, which is much less interesting. So I'm about to run through building and publishing a package from scratch in a moment, but first I'll just run through talking about myself for a moment. This is me. I am GG2K on Twitter, GitHub, and pretty much everything else. My real name is Mark Smith, and I'm a developer advocate at Nexmo. We're a sponsor of the conference. I stole this slide from my colleague, Aaron. He complained about that before, so I thought I'd give him some credit this time. We offer web-based APIs that allow web developers to write code that sends text messages, makes phone calls, sends messages via different instant messaging platforms. If that sounds interesting, we are around for the rest of the conference. Come and talk to me or Aaron, who's wearing a hoodie the same color as mine. And that's enough about me. I've got a lot to get through in a really short space of time, so I'm going to talk really quickly. Whoa. This is actually falling apart. Can somebody help me with that? No, I think it's OK. That's new. It just slid forward. OK. I'll keep an eye on it. So in March 2016, a developer removed a library called LeftPad from NPM, the Node.js equivalent of PyPI. It's a big web service containing packages. It broke lots and lots of libraries that depended on it. LeftPad had been downloaded 2,486,696 times in the month before it was removed, so it was very popular. It was just one function and 11 lines of code that padded a string to a certain length by adding characters to the start of the string. Lots of people thought that the existence of this library made the JavaScript community look kind of stupid. Why would anyone publish a library consisting of just 11 lines of code? Why would anyone use it? Now, the fact that it could be removed like this and cause these huge problems in the JavaScript ecosystem is a problem. But I think, in general, the existence of this library actually made the JavaScript community, and especially NPM, look amazing. And if you disagree, you can fight me on Twitter. LeftPad was not a problem. LeftPad was a solution. It was because the JavaScript standard library doesn't contain a solution for adding white space to the start of a line, the developer of LeftPad solved the problem himself and published the solution for other people to use. And because it's really easy to share code on NPM, people do, with really small libraries, the type of thing that you would normally, in other languages, find on Stack Overflow or on a gist. But copy and paste is not how you should share code. I think we all agree. But I think people in the Python community are kind of afraid of setup.py files. Over the years, the docs and best practice have been a bit tricky to put together. Opinions have changed over time. There are differing opinions online, so it's just difficult to work out how to do things properly or even whether you are doing things properly. But they are getting better all the time, and hopefully this talk will help in some small way. So every time you publish code on a shared repository, you make the Python ecosystem stronger. You make somebody's life easier, and these are all good things. Where would we be if Django, NumPy, or Pandas had never been published? So let's make a package. So the idea of this talk really is that you're working on a project, and you've written some code, and you realize it's not that specific to the project, so you want to share it with other people. So, well, let's start with some code that could be useful to other people. I mean, I'm sure everybody in this room has had to write this code from one time or another. Wouldn't it be better if you could just pip install it and call it? So the first thing to do is extract the code. And here we've extracted it into a file called hello-world.py. And we put it in a source directory. I'll explain that in a minute. And the next step to make this a publishable package is to write a setup.py file in our hello world directory that contains all this stuff. So this is about the simplest setup.py file you can write. So we're using setup tools, which is a third-party dependency, and it never used to be necessarily recommended unless you needed the extensions that it provided. But these days, setup tools is a dependency that pip has. So you already have setup tools available. It's more powerful than distutils, so we're going to use it. So we import setup, and although we're calling a function, really all those arguments passed to setup are just kind of metadata describing our library. So the name of our library is Hello World. So this is what you will pip install. This is how it will be looked up in the PyPI database. We've picked a really low version number because we're probably going to be iterating several times as we get the package kind of sort of solidified in the early stages. I've written a description here, which isn't very useful, so you would write a one-line description and put it in here so people can kind of understand very quickly what the library does. And then in PyModules, although it looks, in this case, it contains the same thing as name, and it often will contain the same thing as name, this is what you import. So it's not what you pip install, it's the PY file, essentially, that's going to be copied into the package and uploaded to PyPI. And then this last line is needed because we have a source directory, which I mentioned in the previous slide. It's kind of a magic copy-paste thing. Just do that. So let's test it. We're already at the stage where we can build our package. So we call the setup.py file with this bdist_wheel command, which is short for build me a wheel binary distribution file. Wheel is the file format that is currently the standard for pip. And we get lots of output that comes out of this, which I've cut lots of that out. But the important line is the one that I've highlighted, which says that it's copied our source code into the library folder. So that's a good sign. And now our project looks like this. So it's created an egg info folder, which I kind of hate, but we'll just ignore that for the rest of the talk. We have a build folder, which contains the source code. It's essentially copied our source code into the build folder, so that's good. And then it's zipped it up into this WHL wheel file, which is what we wanted. So we know that it builds. We didn't get any errors, but we don't know if everything that we need is in there. So let's install it. So we installed the package we just created into our own virtual env running using this command, this pip install command. But you may be wondering what this -e dot thing at the end is. So the -e flag means you're installing it as editable code. Now what this means is it's not going to copy the source code in the source folder into the virtual env, into the virtual env's library folder. Instead, it's going to link that virtual env in. It essentially adds that to the Python path, so that when you can import Hello World, just even though it's not, in fact, the point is it's importing the file that you're editing. So everything you're editing in source is the thing that's being imported in your current virtual env. And then, oops, excuse me, the dot at the end just means you're installing the current directory. So it runs the setup.py in the directory that you're currently in. So it installs our Hello World distribution. So the end result here is that your Hello World library will now be importable into your virtual env. So let's test that. So we can run Python, we can import Hello World, we can import say hello, we can call it a couple of times. This is going to get a bit tiresome if we have to do this every time to make sure our setup file is still correct, so we'll sort that out in a minute. So in theory, we can upload this to PyPI already, and you might want to do that just at this early stage to make sure that you're reserving the name of your package so that somebody else doesn't take it, and just kind of make sure that your basics are set up. But I would say that really before we publish to PyPI, there are three things we need to do first. We've got documentation, testing, but first a little bit of housekeeping. So you need a gitignore file. As you've seen, we've just built the project, and it's created this dist folder, the build folder, and stuff. You don't want to because those are generated files, you don't want to add them to Git. There's a great site here called gitignore.io. You just type Python in that text box, hit create, and it will spit out a bunch of text of common artifacts on Python projects, and you can just paste that into a gitignore file. Then we need a license. Chooselicense.com is a great human-readable site, human-understandable site for understanding what powers you're granting your users. And so I recommend going through that. Eventually, it will give you the text of the library that you're looking at, the license you're looking at, and you paste that into a license.txt file. And then finally, there's some metadata that you should really add to your setup file. So I don't know if you noticed the F string in that function. That means that was only introduced in Python 3.6. So here's some classifiers that say specifically it's a Python 3 library, and more specifically it's a Python 3.6 and 3.7. It's 3.7 compatible. And over time, as new releases of Python come out, you'll want to test it on those and update this so that people understand that it's compatible with the version of Python that they're using. I've also just put in the fact that we're using the GPL v2+ license on this particular package, and I've said it's OS independent because we're not doing anything native to any one platform. So now we come to documentation. First, you need to make a big choice. Essentially, up front, you need to pick the file format that you're going to use for your documentation. You can choose, there are other options, but generally it comes down to restructured text or Markdown. They have various trade-offs. Restructured text is slightly more powerful. It's very well known in the Python community, but not so much outside. And you can use Sphinx to generate a static site of documentation using restructured text. If you choose Markdown, it's simpler, and other language communities understand it more. And you can use MakeDocs, which is basically the equivalent of Sphinx, but for Markdown files. Both of those support read the docs as well. So if you're planning to publish your documentation to read the docs, it doesn't matter which of these two choices you make. I'm going to choose Markdown just because it's quick and easy. So we write a README file with .md to say it's a Markdown file. You should give it a title, which is the name of the project. You give it a one-line description of what the project is for. You should have installation instructions in there, which is just very simple. And you should have some basic snippets of code examples to show how the library might be used. And in some projects, this may be all you need. In other projects, you will want to use Sphinx or MakeDocs and upload and publish to read the docs. Now we have a README, we've kind of got a long description of the project. And that's a handy thing to publish to PyPI. When you're looking at packages on PyPI, you'll notice that they usually have essentially a copy of the README from their GitHub page. So that's exactly what we're going to do. Because the setup file is Python code, we can open the README file, read it into a variable, and then we can provide it to our setup function as the long description argument. And then this last argument here is a nice thing these days is that PyPI now supports Markdown, but we have to tell it up front. So we tell it that the content type is of text Markdown, and it supports plain text, REST, or Markdown these days. So now we want to test, and I would recommend using PyTest, because PyTest is awesome. But this now means we have a development dependency, so where other contributors will need to install PyTest. So we need something like a requirements.txt file or a pip file. Now, I'm getting a lot of usage out of pipenv these days, so we're going to use Pipfile because it may be new to some members of the audience, and it's kind of new and fun. So we need a pip file. So we don't need to write this ourselves. Once we've got pipenv installed, it will essentially maintain this file for us, mostly. So the first thing to do is to tell our developer dependency file that we want to install the current module. So this is a kind of a copy of our pip install -e dot, but now it's pipenv, which means it will also store this information in the pip file. Then secondly, we install our development dependency of PyTest, saying that we want something compatible with, well, up 3.7 and up. And then we run pipenv shell. So pipenv also manages your virtual env for you. So shell will drop you into the virtual environment it's created with the other two commands. So this creates a pip file. These are pretty straightforward, except for this first highlighted line, which is what our -e dot command stored. It's got like a magic string at the start, which I don't understand. It's got path equals dot, which makes sense. It's got editable equals true, which kind of speaks for itself. And then we've got our dev packages that we depend upon, and we've got PyTest, and it's said greater than or equal to 3.7. So this means when other pipenv users download our project, they can just run pipenv install, and it will install all this stuff for them, which is kind of cool. But the really cool thing about pip files and pipenv is that it also creates these lock files. So as well as storing this information in the pip file, it also installs them. It goes off to PyPI. It says, what versions of PyTest do you have that are greater or equal to 3.7? And it found 3.7.2. And it installed it for us. And then it stored that exact version in the lock file. You could commit this file to GitHub when other people, or to Git rather, and then when other people are installing your project using pipenv, they will get exactly that version that you're using. And then when you want to upgrade, when there's a new version released that's compatible with your specifier, you can run upgrade, and it will update your lock file and install the newer version of PyTest that's available. So it can keep you up to date, but you would only commit that after you've run your tests, which kind of keeps you stable. So now we have two dependency lists. Well, we don't, because this setup file doesn't have any dependencies. But if we did, it's for production dependencies, like Flask or Click, NumPy, Pandas. And the version should be as relaxed as possible, because you don't want to force your users to use exactly the same version as you. If your library can be compatible across multiple versions of your dependencies, you should do that. And then your user gets to use their favorite version of Pandas, and you're not locking them into a specific version. So when you can do that, you should. Pip files are slightly different, although versus requirements files, where you should be as specific as possible, you can use the same type version specifiers in your pip file because it locks in the versions in the lock file, as we just explained. But this is for development requirements. So it's the things other developers need to work on your code or run your tests. So it's things like PyTest and mock and coverage. So now we have PyTest installed. We can write some tests. Anybody who's worked with PyTest before will know how simple it is to write sort of simple tests, and then it scales up nicely using fixtures and things like that. So here's some tests that just test that the output of our function is what we expect, and then we can run them just using PyTest, the PyTest command, and then it prints out some stuff, and then it says two tests passed in 0.02 seconds, so that's all good. And so now this is what our project looks like. There's still not a huge amount of stuff there, but it's gradually building up. And now we can essentially publish nicely documented binary distributions now. So that's good. But the other type of distribution that sometimes gets overlooked is source distributions. So for whatever reason, when other people can't use Git to pull things down, or they can't access PyPI, they may need to get a tarball of your code that they then audit and then stick into their own repository. It's the way companies like Google and Facebook work. So we run this sdist command to create a tarball containing all our source code. Really, we want it to be everything that's in Git. So it's all the files that we're distributing via Git normally. So when we run sdist, just as a side effect here, it's telling us that there's some extra metadata it would like. So it would like us to have a URL and some author information. So we just open up our setup.py file and add that in. So yeah, I've added the URL here as my GitHub page. If you had a documentation page, that might be another option. It's really down to personal choice. And then we can just kind of test the tarball by just listing the files that are inside it. So when we look at it, it's done a pretty good job. We've got our Python setup.py file. We've got our source directory with all the stuff in there. But we're missing a few things. We're missing our license file. We're missing our pip files. We're missing our tests. So that's not really a very good source distribution. And the way you fix this is by writing a manifest.in file. And this, I'm not going to show you what this looks like, but it's a file that kind of tells you what type of, it matches certain file names, file types, and adds them to the list of stuff that goes in your source distribution. But they're slightly fiddly to write. They're no fun, and they're easy to get wrong. So instead, I recommend using this tool called check manifest, which is just amazing. And what that does is it tries to create manifest rules that match what's in Git, what you've committed. So it kind of matches the basic idea of what should go in a manifest. So you install it like this, you run check manifest create, and it will actually just store those rules away for you. It's a great way to get started with a manifest file, and then you add that manifest to Git. And then when you run your sdist command again and then list out the contents of your tarball, we get things like the pipfile lock. But just to make sure before you run check manifest create, you have committed the files to Git, because that's the point of check manifest. So now we're really at the point where we can publish. So let's get this thing on PyPI. So here we run our setup command. We tell it we want to run we want to create the wheel. We want to create the source distribution. And then afterwards, we can just check that those have appeared in the dist folder. So you can see we've got a wheel file and a gzip tarball. And then we want to push those to PyPI. And it's really simple. You go onto PyPI, you create an account. It will prompt you to create a username and a password. And then we want to use Twine to upload. So there's the setup tools can automatically upload your stuff, but you shouldn't use that command for various reasons, one of which is that up until relatively recently, it was insecure. Twine has been insecure from the start. It also separates building your distributions from uploading your distributions. So you can build your tarball and check it rather than building it and uploading it and hoping that you got it all right. So it's really easy to use. Once you've installed it, you run twine upload and then give it a list of files that you want to upload. So we're using a wildcard on our dist folder. We just want to upload everything that's in there. And it prints out a bunch of stuff telling you it's uploaded. And then you go to PyPI, and they have a box there that says like recently updated, and hopefully you should be in that box if you're quick enough on the browser. And here's our library. So I've renamed it slightly because obviously somebody's already uploaded a package called Hello World to PyPI. So I've added my username to the end of that. It tells you how to install it. It's nicely formatted our Markdown README in the page. Down the bottom where you can't see, there's a link to our GitHub repo. I mean, it's pretty much what you expect to see with a published package. So those are really the bare essentials for publishing a package. We've got some tests, some documentation. We've published the package so that people can use it. I would recommend doing a few other things, but maybe you can publish first before moving on to the other stuff. It's better to make stuff available than to perfect it. If you're constantly trying to perfect it before releasing it, you'll never release it. So one of the things I'd like to fix next is that we should really test against different versions of Python. And there's a tool called Tox, if people haven't heard of it before, that does exactly that. So a Tox configuration can be really simple. This one is fine for this current project. So this is really 3 lines of configuration. The first one says we want to test under Python 3.6, Python 3.7. And then we say our dependency is PyTest for running the tests. And then we say to actually run the tests, run the PyTest command that they just installed in the previous line. So what Tox does is it creates a virtual environment that for 3.6 and 3.7, in this case, it installs your package into that environment, and then it runs the command that you told it to run. And assuming that runs with a 0 exit code, then everything's fine. So running it looks a bit like this. So we just run the Tox command. And you can see that it's running under Python 3.6, and then it's running under the alpha version of Python 3.7. And then further down, assuming everything goes OK, we get this nice summary saying command succeeded, command succeeded. And if all the different virtual ends pass, you get this nice congratulations line with a little smiley. But one thing I wanted to highlight, so I mentioned this earlier, why we have a source directory, is that when Tox runs your tests, your current working directory is actually that top-level directory, the one that we're working in, the one that contains our setup.py. And when you're running Python commands, your current working directory is in your Python path. It's the first thing in your Python path. So if it's looking for a file called helloworld.py, it will load that one in the top directory. It won't load the one that was installed by your setup.py. So you can end up in situations where your setup configuration is wrong. It will work, but like it's not copying the hello world file into your virtual env, but your tests will still all pass. So this is why we have a source directory, is to just move our code out of the importable path unless it's specifically installed. So again, this is why we need to run pip install -e dot to install it just once. Yeah, it just stops us from accidentally importing the wrong copy of hello world. So that Tox allows us to create these kind of contained environments on our machine and run tests inside them. And that's great, but developer machines are messy things. We have things in our path that maybe we're not using all the time. We have environment variables set that may affect the running of your tests. Really, what you want is a container or a virtual machine to run these tests for you. And there's nice services like Travis, if you've got an open source library, will do this for you. And all you need is a Travis configuration file that you push to GitHub. And this is all free. So this is what a basic Travis configuration looks like. We say it's a Python project. We say we want to run it under Python 3.6 and the development version of Python 3.7. And then we tell it how to install our project, which in this case is just pip install tox. It will automatically install from our setup.py as part of the whole kickoff before the tests. And then it will run the script that you ask it to. So in this case, we ask it to run tox in a verbose mode in the environment py. So this is something I only learned recently. If you ask Tox to run the py environment, it will pick up whatever the available Python is. So we're using the Python that Travis installed for us. It creates a virtual env out of that and then runs your tests inside it. So every time we commit now, Travis will pick it up, create a couple of virtual machines, and run our tests, and then send us a message on GitHub to say that our tests passed or failed, which is kind of cool. And it makes working with other developers easier. It makes contributing easier because contributors can see sooner rather than, well, without you even saying anything, the contributors can see that their pull request doesn't pass the tests, and that allows them to fix it before you ever need to go and have a look at it, which is good. So for extra credit, there's other stuff you can do. So we should add badges to the top of the README to give people more confidence in the project. A simple badge to add is often code coverage using one of these other services like coveralls and codecov.io, and they all integrate really nicely with GitHub. We can add quality metrics where they essentially run linting on the code and tell you possible mistakes you've made or formatting errors and things like that. Bump version is a really nice tool for managing your version numbers, and it will automatically tag your commit to tell GitHub that essentially you're making a release. You should test on different platforms. You can write more documentation. You can always write more documentation. This is really a lot of work. I mean, I don't know if you noticed that. and I've run through all this in half an hour. I mean, really, if you're going through this in detail, it takes quite a lot longer. This is maybe a day or two's work to really kind of refine all this stuff. So what I recommend is that you don't do any of this. So this is like the biggest bait and switch I've ever done in a talk. So at least now you know why you do all these things, or kind of how they all go together. But it's repetitive, it's error-prone, and it's kind of boring. You know what's really good at fixing problems that are repetitive, boring, and error-prone? So tools on computers. So in this case, we've got code that writes code. There's this awesome project you may have heard of called CookieCutter, which is it runs through a template and sort of builds directories full of files and folders. It can ask you a few simple questions to change, to customize the things that it's making for you. And you've got templates for a whole bunch of things, like Ansible configuration, and but among other things, creating new Python projects, which I think is what it was really designed for in the beginning. So let's just for a moment pretend I didn't spend 25 minutes telling you how to build a project from scratch. And instead, we'll use CookieCutter. So the first thing to do is install CookieCutter. And then we run CookieCutter, and we give it a path to a specific template. So in this case, we haven't even downloaded the template up front. We're pointing it at a template called CookieCutter PyLibrary, which is maintained by a guy I vaguely know called Yonel. And I'd love to pronounce his surname, but it's got accents I've never seen before in it, so I'm not even going to attempt that. He's also written a bunch of blog posts on good packaging practices and easy mistakes you can make when you're packaging. So those will be up on the repo for this talk, probably later on today or tomorrow. So first, it asks you lots of questions. It asks you lots and lots of questions because whereas I've given you sort of a single path through building a package, this package, it can work with PyTest, it can work with Nose, it can work with unit test, and it wants to know which one of these things you want to work with all the time, and a bunch of other services it can integrate with. So it asks you lots of questions, but it's still quicker than writing those config files by hand. And then once it's generated this folder full of files, you copy in your own code and tests. You'll need to make some minor file tweaks to the configuration it has generated for you, so to specify the versions of Python you want to test against and things like that. And then you're done. And the end result looks a bit like this. And so when I last ran through this process, this took me 5 minutes. So it did take a little bit of manual configuration, but it took me about 5 minutes from beginning to end, and I could have pushed it to PyPI if I'd wanted to. So I could have cut this entire talk down to 2 slides. In fact, really, this is a lightning talk that I just spent 30 minutes giving. So if I'd wanted, instead of wasting all your time. But hopefully this gives you a good overview of good packaging practice and encourages you to publish your own packages on PyPI and maybe understand what's going on under the hood. So these slides and a bunch of supporting material and a bunch of references will be up on GitHub tomorrow, probably. I recommend you follow me on Twitter, but that's because I like what I publish on Twitter. Thank you very much.
We have a little gift for you. Thank you so much for speaking. He's not going to be taking questions at this time, but you could probably talk to him out in the hall.
Absolutely, yeah, I'm around.
And the next talk here is going to be at 2:50, so in about 10 minutes.